Hi everyone, myself Dr. M. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering. In this video, I am going to discuss about how we are going to address the missing data in the analysis stage. So, what are the different types of methods that are available here? So, in order to identify the missing data, since we are going to get the missing data from different sources like primary source and secondary source, so there may be a chance of getting missing data. So in previous videos, I discussed how the missing data is coming or what are the different types of missing data, right? So now how are going to eliminate this missing data with the help of several methods we will see in this video now. So these are the methods that are available for handling the missing data. So very first one is the deletion methods and second one is that imputation methods. So deletion methods means where where in the table, suppose if I get a missing data, then that type of missing data is going to be deleted. So what are the methods available for that will be the deletion methods. And then imputation methods. So imputation methods are nothing but substitution methods. Suppose in a table I get some missing data, then how we are going to replace this with the missing data with the corresponding value should be imputation methods here. Right. So what are the different types of deletion methods here? So deletion methods are nothing but deleting the cases or the variables if you identify the missing data. So for that we are having listwise methods, pairwise deletion methods, variable deletion methods and imputation methods. So imputation methods are nothing but substitution methods. So there are different types of imputations like single imputation and multiple imputation. So in single imputation means again that should be divided into different categories like mean imputation, conditional mean imputation, case mean imputation, regression imputation, last observation carried forward, worst case imputation, best case imputation and EM imputation. Right, and another one is that multiple imputation. So like this, we're having different methods that are available to substitute the missing value with the methods. So let's see one by one here. So listwise deletion methods means suppose if the size of the data set is 25. So suppose if I identify some missing data here, so that row or column is deleted. So that what will happen is the size of the data set is going to be deleted. So that should be listwise deletion method. And pairwise deletion means suppose if we are going to identify the missing values in consecutive rows or consecutive columns, then we have to apply this pairwise deletion method. And then variable deletion, suppose if I get a missing data for the particular variable, then how we are going to delete that variable. So that should be variable deletion methods. And then when it comes to substitution methods, here substitution methods will be single imputation. So here very first one is that mean imputation. So mean imputation means so the missing value is going to be filled with the mean value. That should be mean imputation. And similarly, second one is a conditional mean. So missing value is going to be replaced with the conditional mean. And third one is that replacing the missing value with the case mean. And then regression. So based on some regression equations also I can able to fill the missing value. And then last observation carried forward. So last observation carried forward means suppose what is the value that I filled previously, that value is going to be filled with that missing value. And worst case, so what I can able to fill the missing value with worst case imputation, or I can able to fill the missing value with the worst case imputation also, and then EM imputation. So these are the different types of imputation methods we are having for handling the missing data. So see the first one here. So listwise deletion. So it is a very good method when the proportion of missing data is less than 15%. And then the advantage is that so it can be used for any type of statistical analysis and no special computations are going to be required here. And then the parameters estimations are to be unbiased, and then standard errors are appropriate when compared to the original data. So these are the advantages of this method. And disadvantages is that it should able to remove the considerable fraction of the data. So that should becomes the disadvantage of this method. So let's see an example here. So in right side I'm having a table here. So in this table I'm maintaining the variables like age, gender and income here, right? Suppose the variable subject 3 is having some missing data in income column, and then variable 4 I am having the missing value in the gender column, gender variable, and then subject 5, I'm getting the missing value in age 5. So like this, right? So in order to do that, what I have to do, I have to fill the missing data, right? So this, since this should be the deletion, right? So what is the variable I'm getting the missing value? So that one is going to be deleted. That should be subject 3 is deleted, and subject 4 is going to be deleted, and subject 8 is to be deleted. So that should be the listwise deletion method. So what are the variables we are getting missing data? That rows are going to be deleted, right? So this method should be very good method. So whenever the proportion rate of the missing data should be less than 15%, then only I can able to apply this method. Otherwise I should not apply this method. And then advantages means, so you can able to apply this method for any kind of statistical analysis. Since we are going to deleting only the rows, right, where the missing data is getting, so that no special computations are going to be required here. And then parameter estimations are to be unbiased, no need of calculating the parameter estimations. And then standard errors are also going to be appropriate when compared to the original data, since the error rate is going to be reduced since I'm going to deleting all the rows. So mainly disadvantage is that so considerable portion of the data is going to be deleted. So that's why the size of the data set is 8. Since I'm going to delete the 3 rows, so what will happen? The size of data set is going to be reduced. So that should become 7. So that should be the disadvantage of this method here. And the next one is that pairwise deletion. So in pairwise deletion, what we are going to do is, so here we are going to drop the cases with the missing values based on analysis to analysis basis, right? So and then the advantages should be, it should be useful for all the available non-missing data. That should be the advantage. And disadvantage is that it should able to estimated standard errors, and then test statistics are to be biased. So these are the disadvantages. So let's take an example here. So see the right side, I'm having the example here. So what will happen here in subject 3, I'm having a missing data in income column. Similarly, I'm having a subject in subject 4 also, I'm having some missing value in gender variable, and subject 8, I'm having a missing value in age. So pairwise deletion means, so whenever the 2 consecutive rows having this missing data, so I can able to delete one of the missing data. That should be the pairwise deletion, right? So pairwise deletion means, so whenever I'm going to get the missing 2 values consecutively in a table or in a data, at that time what will happen is we have to delete one of the missing value. That should be pairwise deletion here. So in pairwise deletion, what we have to do here, going to drop the cases, so based on analysis to analysis basis. So first of all, we have to check it out whether the missing data is coming here in first subject or not. Similarly, I have to identify whether this missing data is getting in second subject or not. Like this, I have to analyze all the data fields. So whenever I'm getting the 2 consecutive missing data, that data is going to be deleted through based on the analysis to analysis basis. So advantage is that, so it should be available only for the non-missing data. That should be the advantage. And then disadvantage should be the standards errors are going to be estimated, and the statistics are going to be biased. So this is the disadvantage of this method here. And then next one is variable deletion. So variable deletion means, here we are going to drop the variables with the missing values based on case to case basis. So in case to case basis, we have to drop the variable which is having the missing value. So advantage is that it makes sense of a lot of missing values in the variable, and if the variable is of relatively less importance. So suppose if I'm going to consider an application, right? So in that application, what I have to do, suppose if the variable is having some less importance, some variables having very less importance, when some variables is having more importance, right? So at the time, what you have to do, variable which is having the less importance for that application is going to be deleted. And then disadvantage should be the loss of information regarding the variable is going to be disadvantage of this method here. So let's take an example here. So take a right side, we're having an application like this. And then what will happen, suppose I'm going to calculate the income of the persons of different ages. I want to calculate in this particular company I want to do. So in that application, what I'm going to do is the subject is I'm taking the way age is one of the variable, and then gender is another variable, and income is another variable, right? So what will happen is, if I'm going to take age, so age is important when compared to the gender variable, and income I'm taking. So income is very important since I'm calculating the income is the application. So what we'll have to do is, we have to identify the which variable having the less importance and which variable having the high importance. So if I'm going to take age, so that is having some much more importance, and then gender, so gender is having less importance when compared to age, and then when compared to income, and income is having very more importance is having it, right? So at that time, what I have to do is, so I identify the variable which is having more importance, that one is going to be deleted here. So since the gender is having less importance, so what I have to do, I'm going to deleting this variable, right? So in variable deletion, what we have to do, we have to going to drop the variables with the missing values based on case to case basis. And advantage is that, so I have to make sense when a lot of missing values in a variable is of having less importance, and disadvantage is that, so loss of information regarding the variable is to be disadvantage of this method. And the next one is that main imputation. So next we are going to see about the substitution methods. So in that one, the single imputation is the one of the type. So in that one, so we are going to calculate the mean imputation here. So what is the mean imputation means? So we have to replace the values with the mean of the variable, that should be mean imputation. So what we have to do is, suppose consider the example, see on the right side, we are having three variables here. So the variable 1 is getting the missing value here, and then variable 3 is getting the missing value here. So what we have to do, so I have to calculate the mean value of this entire variable. Suppose if I'm going to get the 7.44 is the mean of that variable 1, so that value is going to be filled with the missing value. Similarly, I have to calculate the mean value of entire variable. Suppose if I'm going to get the mean value as 6.59, so this value is going to be replaced with the mean value, missing value, right? So like this, we have to fill the missing values with the mean values, right? So the mean imputation means where you have to fill the missing values with the mean of that variable. So for that, what you have to do, you have to calculate the mean, we have to calculate it, and then so that mean value what I'm getting for the variable is going to be filled with the missing value. So in variable 1 I'm having the missing value here, right? Similarly in variable 3 I'm getting the missing value. So for that, what I'm doing, I'm going to calculate this mean of this entire column, that one is going to be filled with the mean value. Suppose if I'm going to get 6.59 is the missing value, so that one is going to be filled with the variable 3. And then conditional mean imputation. So in conditional mean imputation, so what I have to do is, so here we have to replace the missing value with the variable mean of the relevant subgroup, right? Suppose here I have previously what I did, I am going to calculate this mean value, and then what are the mean value I'm getting, that one is going to be filled with the missing value, right? So here I have to fill based on the conditional mean. So based on conditional mean, I have to fill it. Suppose if I'm going to take an example here, so variable 1 is having missing value in here, and 6 is another variable having the missing value here, and then in variable 3 I'm getting the missing value here. So these are the missing values. So how can I able to replace this missing value with the conditional mean is the problem. So what is the conditional mean? So I have to check it out. Suppose what is the condition I'm writing here is, suppose if this variable 1 mean is greater than 10, fill missing value is equal to sum 15. Else if the variable 1 mean is less than 10, so fill the missing value with 8. Else if variable 1 mean is greater than 5, the missing value is equal to 3. Else, sorry, else missing value is equal to 0. So like this, initially I'm going to define one conditional here. So conditional mean here. So based on this, I have to fill it. So for that, what I have to do, I have to calculate the mean value here. Suppose the mean value what I'm getting for this one is 9. Suppose what will happen? So this condition is going to be satisfied here. So what is this condition? If the variable 1 mean is less than 10, I have to fill the missing value with 8. So that value is going to be filled here. So this is one of the example of the conditional mean. So similarly for this also 6 also I have to write one conditional mean. So based on that I have to fill it. So similarly in variable 3 I have to calculate the mean value. Suppose if the variable value what I am getting is 6 for the variable 6, variable 3. So what is the condition satisfied? Variable mean is greater than 5. So the missing value is 3. So that 3 is going to be filled with the missing value. So like this I have to fill with the missing values with the conditional mean. Right? So in conditional mean what you have to do is you have to calculate the missing values, mean value of the variable based on the conditions. That one is going to be filled with the missing value. So this is one of the applications. So what we have to do, I'm going to calculate the mean. Initially I have to define one conditions mean. So based on that I have to fill the missing value. So here what I am going to, I have to calculate the mean value of this variable, and this mean value is going to be filled based on the condition. So that value is going to be filled here. Similarly in variable 3 I'm getting the missing value here. So for that, based on, I have to calculate the mean value of this variable. Suppose if I'm going to get 6 is the mean value. So that 6 mean value. So what is the condition? It satisfies 3. So 3 is going to be filled here. That should be conditional mean. And the next one is that case mean imputation. So what is case mean imputation? So here what you have to do is, so you have to replace all the missing values. So with the information from from other variables for the same case to impute the missing value, right? So here we have to calculate the missing value. You have to fill the missing value with the values, what information that is getting from the other variable for the same case to impute the missing value. So case mean, suppose let us take an example on the right side. So this is the table we are having here. So in this table what you have to do, in variable 1 I'm getting the missing value here, and variable 3 I'm getting the missing value here. So how the case mean is to be done? Suppose, so case 1, so if the mean value of variable 1 equal to 9, so I have to fill with missing value is equal to 6.50. And then case 2, so if the mean of variable 1 equal to 8, fill with the missing value with 7.5. Case 3, so if the mean of the variable 1 is equal to 7, then the missing value is equal to 6.3. Break. Like this I'm writing here, breaks here. So this is the case mean. Suppose what I am going to do is, so here I'm going to calculate the mean of this variable 1. So for this what I have to do, I have to fill with the check it out. So whether what is the mean value I'm getting. So suppose if I'm going to get the mean value is of the variable is 9, so 6.50 I have to fill it like this. I have to, based on the application I have to write it here. And similarly in variable 3 I'm getting the missing value, so I have to calculate the mean value here. So if the mean value what I'm getting is suppose is 7, so what will happen? The 7 is getting, so the case what is satisfied is case 3. So what is the missing value? 6.3. So 6.3 is going to be filled here. This should be the case mean. So like this we have to fill the missing values with the case mean. So look at this look at this problem once again. So how to case mean, what you have to do, you have to fill the missing values with the information from the other variables from the same case to impute the missing value. So for that, what I have to do, so I have to write some kind of case mean statements. So calculate the mean of the variable and the case what it satisfies. So the corresponding value is going to be filled here. Similarly, in case 3, calculate the mean value of this variable of the same case, and then suppose based on the mean value what I'm getting is 7, right? So that value is going to be filled with the missing value. This is one of the type. So what is the another type here is, suppose I'm getting the missing value here. So here also I can able to calculate the mean of this variable, and then what I have to do, I have to satisfy which condition is satisfied. Suppose the mean value of this variable is 7. So what will happen? 6.3 is the value. So 6.3 is going to be filled here. Similarly, I have to calculate the mean value of this one. Suppose I'm going to get 8 or 9, what will happen? So then 6.50 is going to be filled. So like this, I can able to fill the missing value based on the variables of the same case. That based on that, I have to fill the missing value. That should be the case mean imputation. And then next one is the regression imputation. So what is meant by regression imputation? So here regression imputation means we have to fill the missing values with the information for complete cases in order to predict the value of the missing data. So based on regression equations of the cases with the non-missing values, right? So regression imputation means, so we have to fill the missing values based on some regression equations. So based on the variable based on the regression equation, so the value what I'm getting from the equation is going to be considered, and I have to predict that, and I have to fill with the missing value. So let's look at this. So this is the table we're having. So I'm getting the missing value here in case 2, and then similarly I'm getting the missing value in case 3. Case 9 of the variable 3. So I can able to fill this missing value through the regression imputation. So for that, what I have to do is, so this is the regression equation what I created for this example. So variable 1 star is equal to 4.621 minus 0.734 into variable 3 plus 1.139 into variable 3. So this is the equation what I created. So for this, what I have to do is, I have to fill the values. So for this, what I'm going to fill, right? So variable 1 is equal to, so 4.621 minus 0.734 in variable 2, so that is 7, plus 1.139 into variable 3, that is 6. So what I'm getting, 4.621 minus 0.734 into 7 plus 1.139 into 6. So like this, I have to calculate some value. So what I'm getting 6.3 is the value I'm getting. So that value is going to be filled here. So right. So like this, I have to fill the missing value based on the regression equation. So this is the equation one getting. So let's see the another example here. So here, what I'm doing is, so I'm getting missing value in variable 3 in 9th case, right? So for this, what I have to do, so the variable 1 is how much? 7. So 4.621 minus 0.734 into 8 plus 1.139 into variable 3 I'm taking, right? So otherwise, we simply satisfy this equation, calculate the variable 3 here. So I can able to do that. So take it out. So variable 1 minus 4.621 equal to 0.734 into variable 2 plus 1.139 into variable 3. So again apply this. So variable 1 minus 4.621 minus of 0.734 into variable 2 is equal to this, and final divide with 1.139. So that should be variable 3. So variable 3 is equal to, so variable 1. So what is the variable 1? 7, how to fill it. And variable 2 is 8. So calculate this equation for variable 3. So that what will happen? So I'm getting some values like 6.09. So that value is going to be filled here. So like this, I have to fill the missing value with the regression imputation. Right? So I can able to fill. So here you can able to fill the missing values with the regression equation with the missing values to predict the missing values and fill with the equation based on the value what I'm getting, that should be filled. And the next one is the last observation carried forward. So here what we are going to do is, so here you have to fill the missing value with the value based on the same outcome that the most recent time what we observed. So that should be, I can able to identify the variance, or I can able to fill the missing value with the average of T1 and T2. So since I'm getting the missing value in T3. Right, so the last observation carried forward means, so where I'm getting the missing value, so that missing value is going to be filled with the outcome that occurs most recently that was observed. So that one is not going to be filled it. I can able to fill with the variance, or I can able to fill with average. I have to take it out of the previous two columns. So that one I have to take it out and I have to fill with the missing value. Suppose, so here I'm getting the missing data right in 3.3. And then similarly I'm getting the missing data in T1. So what I have to do, I have to take that average of T2 and T3, what I'm taking. So that one is going to be filled here. So similarly I have to fill that average of T1, T2, I have to take it out. So that average is going to be filled with the missing value. So that should be the last observation carried forward. Right. So what should be this average of 7 and 6. So 7 and 6 approximately 6.5. So that one is going to be filled. So round off means 7. So 7 is the value I'm going to fill here. Similarly, what will happen? So here I'm getting this missing value of 7.5. The average of T1 and T2 is 7.5. So round it off, that should be 8. So that one is going to be filled with the missing value with the 8 here. So this should be the last observation carried forward. And then next one is that interpolation. So in interpolation means, so this is also one of the way to fill the missing data here. So here what I have to do is some interpolation. So some mathematical calculations is going to be carried based on the application, how to construct that value what I'm getting. So that value is going to fill with the missing values. So mainly this interpolation only mainly useful for the longitudinal data sets, right? So this is one of the example of this interpolation, the graph what I'm obtained. So interpolation mainly useful for the longitudinal data sets only. And then, so based on some mathematical equations what I've defined based on the interpolation, so that one is going to be considered here. And then the value what I'm getting for this is going to be take it out and I have to fill with the missing value. And the next one is that best case imputation and worst case imputation. What is that? How can I able to fill this missing data with these cases? So the worst case case means the worst case value is going to replace the missing value with the worst case scenario of for a categorical outcome. Similarly, the best case value replace the missing value with the best case scenario for the categorical outcome. Right. So the worst purpose consider application here. So similarly, there should be definitely worst case and definitely there should be a best case, right? So based on the application, I have to take it out. So similarly, that's missing value what I'm obtaining. So that one is going to be filled with the worst case value. I can able to replace the missing value with the best case value. Suppose I'm going to calculate the temperature of the different and persons due to COVID and all. I want to find it out. So what will happen? I'm taking one example, P1, P2, P3, these are the 4 persons I'm having, and the temperatures I'm having here. So age I'm factor and then temperature is the another variable I'm taking. So let it be 65, 15, 25 and then 32. These are the ages of the different persons. And then what will happen? I'm granting some temperatures like 99.2 and 98.6 and 98.9, and then here I'm get the missing data here. So I can able to replace this with the worst case. So worst case means, so first I can able to replace this value with the worst case. So let it be 97.6, or I can able to replace with what should be the worst case. Normally it should be 100. So suppose, since I'm considering COVID patients, the temperature is 100, around more than 100, right? So that's what I have to do. I have to fill with the missing value with the 100 degrees Fahrenheit and take it out. So this should be the worst case. And best case, suppose normally suppose this person may have COVID and may not have COVID. Suppose the person is having the COVID, so what will happen? So the temperature will be 100 degrees, 100.6 degrees Fahrenheit. Suppose if I'm going to fill the missing value with the best case, so what will be the best case? 98.6. This is the normal body temperature, right? So this one I can able to fill with the missing value based on the best case scenario, and this should be based on the worst case scenario. So this is the data I'm getting. So I'm having the persons of 4 persons of different ages, and the temperatures I'm going to calculate it. So whether the particular person is having COVID or not, I want to take it out. Then I have to fill with the worst case. Suppose if the person is not having COVID, then I have to consider the best case. So like this, I can able to fill the missing data what I'm getting from different sources. That one is going to be filled with the best case and then worst case also. And then next one is that missing data based on expectations. So that should be maximization. So maximization in the sense where you can able to subject best missing value with an ML imputation. So ML means maximization imputation. I can able to carry it out. So in each step, what we have to do, I am going to calculate the expected values based on all complete data points, and then that should be the E step we're going to call it as. And in M step, so there is another step. So here we are going to calculate some procedure that can able to replace the missing value with the expected value based on maximize the likelihood function in order to obtain the new parameter estimations. Right, so this maximization is one of the case where you can able to fill the missing value, and then what we have to do, we have to fill that missing value based on 2 steps here. So first step should be E step, and second step should be M step. So in each E step, what we are going to do is, so what is the values, expected values I'm taking, right? So that one is going to be calculated based on all the data, complete data points here. And then next one is that M step. So M step means where you can able to apply some procedure to from the values what I'm getting from the E step, and then we have to apply the maximization function to the likelihood function to obtain the new parameter estimation. So let us take one example like traveling salesman problem I have. So the traveling salesman problem is the problem, so where the salesman has to sell all his goods from one city, and he has to move to the another city. And final problem is that where this person has to salesman has to sell all his all his products in city 1, and then he has to move to the another city, and then again he has to sell products, and again he has to move to the another city. Like this, he has to visit all the cities and sell his products. So for this, what we have to do is we have to calculate this. So from this, we have to mention the different costs of the each line. Suppose if the person is want to move from city 1 to city 2, the cost is 6 years. Similarly, if we want to move from city 2 to city 5, the cost is 4. Similarly, if we want to move from city 1 to city 3, the cost is 2. And similarly, if we want to move this side means 2, and this size is 1. So for that, what you have to do is this. Suppose the person salesman want to move from city 1 to city 5 is the problem. So what is this best for? What is the maximization, or what should be the minimization? So minimization means, so the overall cost should be less. So what is the best way? Suppose if I move from city 1 to city 5 and then city 4 to city 5, what is the cost? 3. C1 to C4, C4 to C5. Similarly, what is the another way? C1 to C2, C1 to C2 and C2 to C5. What is the cost? 10. This should be 3. And then what is the another way? C1 to C3, C3 to C4 and C4 to C5. What is the cost? 6. So among this, what minimization if I am going to apply here? So then I have to fill the missing value with the 3. 3 since the minimum cost is 3 here. Similarly, if I am going to apply maximization, so what is the maximum value? 10. So I can able to fill the missing value. For this application, if I got it, then I have to fill with the maximization, that should be 10. So like this, I can able to fill the missing values with the based on maximization, or can able to fill with the minimization. So but here we have to all the time have to consider with the maximization. And then so like this, we're having different types of single imputations methods where you can able to substitute with the different methods. And then another one is the multiple imputation. So multiple imputation also one of the method where you can able to substitute multiple values for the missing value simultaneously. For that, we're having the multiple imputation. So multiple imputation is quickly becoming the gold standard approach to handle the missing values. But the major disadvantage is that the computationally this method becomes very complex. That is the disadvantage of this multiple imputation. So single imputation, what we're having is conditional mean, and gold mean, regression, and then like this best case, worst case. So multiple imputation becomes one of the best approach, but the computationally it should be very difficult, right? So these are the topics what I discussed in this video. So here we're having the deletion methods like listwise deletion, pairwise deletion, and variable deletion. So in listwise deletion, what we have to do is, so what are the methods we're having here? So missing value, so that variables are going to be, rows are going to be deleted. That should be listwise deletion. And pairwise deletion means whenever I'm going to get the missing values simultaneously or adjacently, so what we have to do is we have to simply delete that missing row. And variable deletion means, so the variable is going to be deleted based on the importance of the variable. So whether it is the variable is having less importance or more importance, we have to identify according to the application. Suppose if the variable is having low importance, that variable is going to be deleted. And then mean imputation means, so whether suppose if I'm going to get the missing value, that missing value is going to be filled with the mean value of the variable. And conditional means where we have to calculate, we have to write some conditionals based on the mean computation. So based on that, we have to fill the missing value with the conditional mean value. And case mean, right? So here also we're going to calculate the mean value by considering either row, or I can able to consider either column of the same case, and based on the cases what I'm getting the value, so that value is going to be filled with the missing value. And then regression imputation, so here the variable what I'm getting here, so that missing value is going to be filled with the regression equation. So based on regression equations, I'm getting some values. That value is going to be filled with the missing value. And last observation carried here. So here, how to I can able to fill the missing value with the variance, or I can able to fill the missing value with the average of the previous two columns. That should be the last observation carried forward. And I can also able to fill the missing value with the interpretation. And then I can able to fill the missing values based on the worst case and then best case application. And then maximization and minimization also, by using this you can able to fill the missing value. And then multiple imputation. So but this should be very computationally complex, so that should be the very difficult of this multiple imputations, right? So these are the deletion methods, and these are the substitution methods, single imputation, multiple imputation, and these are the methods that are available, comes under single imputation. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.